Hello, my amazing students. This is Mrs. A, and I want to do those 3 problems on 6.4 so that you will have everything you could possibly need to get ready for our test, which is Tuesday. So I am here in Alabama again at my parents' home, and I don't know if you can hear it, but it's raining, and I'm on the porch, and so I'm hearing all the rain dripping. It's kind of nice. I enjoy being here with my parents. So here is number 5 on 6.4, and the problem said that in number 5 we're going to assume a mean of 74 and a standard deviation of 12.5 beats per minute. We're talking about females, and it says on 5A, if one adult female, is randomly selected, find the probability that her pulse rate is less than 80 beats per minute. Okay, so what we're going to do is we're going to use our cumulative normal distribution. And so what I did here, let me see if I can adjust so you can see my board. Okay, so one female less than 80 beats per minute. Since it's only one, we're going to go with the mean and the standard deviation. Now I went ahead and just used my calculator on this. So I did a normal distribution, and remember, when you're doing the normal distribution, you start at negative 10,000, and then you go all the way up to the 80, which is the X value we're testing for, and then you're going to put negative 10,000, 80, 74, 12.5, okay? Because the original population was told us that it was normally distributed. So we're going to be able to get it straight away from the normal distribution. You could also get it from going to a z-score and then going to your chart in the back of the book. But in order to use your chart in the back of the book, you have to have standardized scores. And these are not standardized because the mean is 74 instead of 0. Okay, so we're going to have to either go to a z-score and then go to the chart, or we're going to just use the binomial CDF, not binomial, normal CDF, just the way it is. So this one right here, we are going to do the first part. We're just going to put in, and I think I still have it on here. Okay, yes. Here we go. All right, so I did the normal CDF, and here's my, let's see if I can get this to show you my calculator. All right, so this is the one that I used right here. Normal CDF, negative 10,000 to 80. 74 was the mean, 12.5 was the original standard deviation. So I got 68.44%, and that is the book's answer. So now I'm going to do the B portion, and the B portion says if 16 adult females are randomly selected, find the probability that they have pulse rates with a mean less than 80 beats per minute. Okay, so now we're talking about the mean of the pulse rates of the individual 16 women. So now we're going to have to use, our mean will be the same, but we're going to use the sampling error, or the standard error of the mean, which is the standard deviation divided by the square root of n. In this case, our n is the number of the sample size, which is 16. 16 were sampled, n is 16, square root of n is 4. So then, in order to get our new standard deviation, or standard error of the mean, we're going to find that we get the 12.5 divided by the square root of 16, which is 12.5 divided by 4. And so now I'm going to do the same thing again, but I'm going to use this one right here. Okay, so this one right here, I did normal CDF, negative 10,000 to 80. 74 was still the mean, but now our standard deviation of the mean has gone down, and you can see that 97.26 is the correct answer and that agrees with the manual's answer key. So we have just big picture here. When we were talking about one female, we used the scores the way they were. We used the population mean and the population standard deviation. We stuck both of those in our normal CDF function. And then when we had 16 women that we were trying to find whether the mean of their blood heartbeat rates was less than 80, then we used the mean, which was 74, but then instead of the 12.5 for the population, we used 3.125, which was the original 12.5 divided by the square root of 16. So what happens, remember, when we're talking about the sampling distribution, the data crunches in. So now on A, it was a 68.44% probability that one woman would be less than 80. But when you take 16 women and the mean is only 74, they're going to clump closer and closer to the 74, and very few of them are going to go far outside that. So now you have more of the women, 97.26% of the women of the means will be less than 80. So the probability that 16 women, the mean of their heart rates is much higher than just one individual woman. Okay, then in C it says, why can the normal distribution be used in part B? And that's because even though there was only 16 as an N for the sample size, the problem said that the original blood pulse rates were normally distributed. So the original population was normally distributed. Therefore, it does not matter what sample size we pull out of it. We can assume it's normally distributed. And that is the end of problem number 5. All right, so number 9 is elevator safety. Example 2 refers to an elevator with a maximum capacity of 4,000 pounds. When rating elevators, it is common to use a 25% safety factor. So the elevator should actually be able to carry a load that is 25% greater than the stated limit. The maximum capacity of 4,000 pounds becomes 5,000 pounds after it is increased by 25%. So 27 adult male passengers can have a mean weight of up to 185 pounds. If the elevator is loaded with 27 adult male passengers, find the probability that it is overloaded because they have a mean weight greater than 185 pounds. As an example 2, assume that weights of males are normally distributed with a mean of 189 pounds and a standard deviation of 39 pounds. Does this elevator appear to be safe? All right, so in doing this problem, we're trying to find the probability that the mean weight in the elevator will be above 185 per male. So we're going to have to do a 1 minus at the end of this problem because remember our normal CDF gives us everything to the left instead of the right, but we're wanting to know what is the probability the mean will be greater than 85 per 85 for the mean of all the weights. So remember we had a mean for the population of 189. We have the standard deviation is 39, but now we're talking about 27 men getting on here, and we're taking the average of all of their weights. So we're going to use the normal CDF, but we're not going to use the 39. We're going to use 39 divided by the square root of 27. So when we do that math, because we're doing a sampling distribution, we're going to get 39 divided by square root of 27 is 7.5. So now when I go do my normal CDF, I've got my negative 10,000 to 185, because I'm doing to the left first. 189 was my mean, but my standard deviation or my standard error of the mean was 7.5. When I cranked that out, I got 0.2969. And then I say, okay, well, that's the probability it's to the left. I need the probability it's to the right. So 1 minus 0.2969 is 0.7031. And the book came out with 0.7030, but either way, I had a little rounding different from the book. That's not that big a deal. But that is how you do number 9. And so we'd say, no, this is the probability that they actually weigh more than they should. 27 men, even if you took it up to 5,000 pound weight limit. So yeah, you would say that is not a safe elevator with the restrictions that they have posted. And that is problem number 9. And the last one that we have to do is number 11. Mensa, membership in Mensa requires a score in the top 2% on a standard intelligence test. The Wechsler IQ test is designed for a mean of 100 and a standard deviation of 15, and scores are normally distributed. Find the minimum Wechsler IQ test score that satisfies the Mensa requirement. So we're looking for the 98th percentile. Okay. If 4 randomly selected adults take the Wechsler IQ test, find the probability that their mean score is at least 131. Okay, well, I'm assuming that 131 is going to be the answer to A, but we're going to do out the work for that. And C says, if 4 subjects take the Wechsler and they have a mean of 132, but the individual scores are lost, can we conclude that all 4 of them are eligible for Mensa? Okay, so let's look at this one. All right, so here's the board for part A, which is just finding that boundary for the top 2% of the score. So I did the 98th percentile using the inverse normal, 0.98, 100 was the mean, the sigma was 15, and I got 130.8, or 131 is the minimum score they should make on the test in order to get into the 98th percentile, or the top 2%. The book also answers that A with a 131, so we're on target there. I can't even get close enough to see that. So in the B portion, we're talking about what is the probability of 4 individuals. And since we're talking about their mean score, we're going to use our standard error of the mean instead of our standard deviation. All right, here is the board for the second part of that problem. We're going to use the normal CDF because we're going from a number to a probability. We're going to do negative 10,000 to 131, and we're looking for the probability of greater than 131, so we're going to have to do a 1 minus at the end of this. We're talking about 4 individuals and their mean, so we're going to use the population mean, 100, but then we're going to use 15 divided by the square root of 4, which is 15 divided by 2, which is 7.5. When we do that, we get 0.99998. So we're going to be doing 1 minus that because we want the probability to the right, which gives us 0.00001789, which coincides with your book's answer. And I've got one more little bit, and it's good because it's starting to get dark out here. Okay, so the last little part, I'm not even going to do the math on that because it's really pretty obvious. It says if 4 subjects take the Wechsler test and they have a mean of 132, but the individual scores are lost, can we conclude that all 4 of them are eligible for Mensa? And the answer is no, because to have a mean of 132, that means one of them could be below the 131 and still have all 4 of them have a mean of 132. And that's exactly what they said over here. They said, no, it is possible that the 4 subjects have a mean of 132 while some of them have scores below the Mensa requirement of 131. So, I mean, that's not a very far jump from 131 to 132. So they're not even showing any math with that one. And that is your homework on 6.4. I hope that you're all taking the opportunity to work on your practice test. And this is Mrs. A, and may God bless your day.